Okay, we're going to graph to solve square root and cubed root equations today, and also learn how to solve algebraically. So we're going to start by graphing. This is a recap of what we did on Friday, so this may be beneficial to you as well. So the first function that we have is the square root of x minus 3. And because this minus 3 is here, we know h is 3. And then it's almost like we have a plus 0 here. So this is translated to 3, 0, so put that in place. And there is an a of 1, which means there is no stretching or compressing, no reflecting. So I'm just going to use what we call our normal moves. When you're talking about a square root, taking the square root of 0 would give you 0. Taking the square root of 1 would give you 1. Taking the square root of 4 would give you 2. So those are what we call our moves from our data table and the way we looked at it on Friday. So let me kind of turn this. So when I go 1 to the right, I go 1 up. 4 to the right, I go 2 up. And that's going to be pretty close to what that's going to look like. Now, solving it graphically, the first step is just to graph your function, which is the square root function. The second thing is to graph the line. And here we have a line at 2. So I'm just going to graph a line at 2, kind of just going across and seeing where it would intersect. Okay. Now, I don't want to put the line on there because then it gets kind of confusing because then I'm looking at a line of 1. So I'm just going to look at where the line of 2 would cross. So the line of 2 would cross and intersect at this point right there. So that value is 3, 4, 5. So an x of 7 is going to give me a y of 2. So this is just going to be x is equal to 7. Now I want to see where the line y is equal to 1 intersects. So when I look across, I see it intersects right there. And now I'm looking for all y's greater than 1 and the x's that give me those y's. So it intersects right here, and I'll go ahead and draw this line in place. And my solution is going to be all x's that give me y's greater than 1. So this is where it intersects. So it's going to be 4 to infinity. And I'm not going to include 4 because 4 actually gives me exactly 1. And that's not underlined, so I need to not include that in my solution. So that is how you're going to do that. So let's do a few more of the graphing. I'm going to skip to, no, let's go ahead and do G here. So G is basically going to shift down 4. It doesn't move left or right, so I'm just going to shift down by 4. Right here will be my translation point. And normally I'd go 1 to the right, 1 up. Because of this 2, I'm going to double my moves or stretch my function. So 4 to the right, instead of going 2 up, I'm going to go 4 up, and that's what that's going to look like. Okay, so the first thing I want to solve for is y of negative 2. So when I go across, it intersects at an x of 1. And if it's helpful, think about the point that you're intersecting, or the point of intersection. It is 1, negative 2. And this is, of course, saying 1, negative 2. So I'm looking for the x of 1 that gives me the y of negative 2. And that's what this function notation is implying. What about where x is less than negative 2? So I'm going to draw that line in place right there. And it's this little piece of the graph where my y's are less than negative 2. And it's actually going to be an x of 0 to an x of 1. So 0, 1. And I'm going to actually include this 0 because 0 for an x is actually giving me a y less than negative 2. But I'm not going to include the 1 because the 1 doesn't give me something less than negative 2. It gives me equal to negative 2. So I'm not going to include that, the 1 right there. This is a little weird situation that exists for the square root. In the past, we've been able to say if it's a less than or equal to, you just always use brackets. It's a little bit different here because I have an x of 0 that is actually meeting this requirement that y be less than negative 2. So we'll do some more of those to make sure you understand what that looks like. Okay, now let's solve a few algebraically as well. And should have finished this up looking at points of intersection and then write your solutions based on the symbol. So in other words, if it's a greater than sign, you're looking for the x's that make y greater than 1. So that's all that means. Now solving algebraically, I think you'll find pretty straightforward, especially since we've done some of these already. Step 1 will be to isolate your radical. Here's the square root. And then remember that it's an understood 2 there, because the second step will be to square both sides. And it's the square of both sides that will cancel that root of 2. So that's why I mentioned that. And then step 3 is just to finish solving. So I'm going to do a couple of these with you real quick. So number 1, the radical or the square root is already isolated. So I'm going to go right in and square both sides. X plus 2 is equal to 25. Subtract 2, I get x is equal to 23. And by all means, pause this anytime you need to, because I'm going to go through these pretty quickly. Number 2, I need to isolate this, so I'm going to subtract 4. And don't forget, we always use reverse PEMDAS here. So then I end up with the square root of x minus 5 is equal to 2. Square both sides. X minus 5 is equal to 4. Add 5, add 5. X is equal to 9 is my solution. Okay, let's do number 3. I'm going to start by dividing both sides by negative 2. So square root of x minus 3 will be equal to a positive 4. Square both sides. X minus 3 is equal to 16. Add 3 to both sides, and x is equal to 19. Okay, number 4. Subtract 6. And I get 3 times the square root of x plus 1 is equal to a minus 3. Divide by 3. I get square root of x plus 1 is equal to a negative 1. And then I'm going to square both sides. And then when I square negative 1, it gives me a positive 1. And then that will be x plus 1. Subtract 1. And I get x is equal to 0. And that should get you going on that concept. Now, flipping over to the back of the notes, this is our cube root function. And it looks something sort of like this from Friday's lesson. So when I move 1 over, I go up 1, 8 over, up 2. When I go 1 to the left, 1 down, 8 to the left, down 2. Okay, and it comes from the parent function data table. That would look like this. And I'm choosing perfect cubes over here. Okay, so this will be shifted 3 to the right and not up or down at all. So just 3 to the right. So 1 to the right, 1 down, 8 to the right. Puts me right about there. 2 up. Same thing. I'm going to go 8 to the left, 2 down. And then there's my graph. Okay. Now, solving these graphically, same exact steps. You graph your function, the cube root, you know what it looks like. Then you graph your line. You find your points of intersection. And then you write your solution based on what you see, or based on the symbol. Okay, so for this first one, I'm looking for where f is equal to 1. When I go across, I see it intersects right there at x of 4. So it's going to be a 4. Then where is it greater than 1? Well, when I draw my line in place, I can see that here is the part of my graph from there that my y's are greater than 1. So it's going to be 4 to infinity. But it will not include 4 because 4 isn't greater than 1, it's equal to 1. Okay, let's graph the next one. So this translation point is 0, negative 4. And it's stretched by a factor of 2, meaning when I go 1 to the right, I go 2 up instead of just 1. And then when I go 8 to the right, I would normally go up 2, I go up 4. And same thing on the left side, 1 to the left, down 2. 8 to the left is going to be down by 4. So it looks something like that. I think I'll move on too far. Nope, that's right. Okay, now, where is it equal to a -2? When I put my line in place, it's equal to a -2 at 1. So there's a 0.1, -2. Where is it less than -2? Well, it's everything to the left here. So all the x's from -infinity up to a 1. It will not include the 1 though, because 1 is not less than -2. And x of 1 gives you exactly a -2. Okay, now let's do one where we have to reflect just so you kind of see what that looks like. So my translation point is -4, +3, and it's going to be reflected. So -4, +3. Normally I go 1 to the right, up 1. Now I'm going to go 1 to the right, down 1. When I go 8 to the right, I'm going to go down 2. So that's what that's going to look like. 1 to the left, normally I'd go down 1, but I go up 1. So I'm reversing the direction of my y's. So my x of -1 would normally give me a -y, a -1 for y, but I'm going to reverse that. So my graph looks something like this. Okay? Now I need to know, where is it equal to 2? Well, it's equal to 2 at this -3. And where is it less than or equal to a +3, which is here. So it's less than in this portion of the graph. So -4 to infinity. And it is underlined, so I want to include that -4 because -4 gives me exactly 3. Now we can solve these algebraically as well. And the steps are going to be isolate the cube root, whatever is underneath the radical, like you're going to isolate the whole radical. Step 2 is going to be to cube both sides, getting rid of the cube root, and then finally just finish solving. So I'm going to go right in with this one and cube both sides. So x plus 2 is equal to 125. Subtract 2 and you get x is equal to 123. Okay, do number 2, subtract 4. I get the cube root of x minus 5 is equal to a 2. Cube both sides, I get x minus 5 is equal to 8. Add 5, and I get x is going to be 13. Number 3 down here, divide by -2, cancel, cancel. That's a +4. So x minus 3 all cubed is a +4 cubed both sides. X minus 3 is equal to 64, and add 3. X is going to be 67. Number 4 here, subtract 6. Bring down everything else, so that will clear out to a 1. And I get a -3, and then I divide by 3, giving me a -1. And when I cube -1, it gives me a -1. So I end up with x plus 1 is equal to a -1. Subtract 1, x is -2. And the final one, add 6. So this gives me 9. And then I'll divide by 3. So then I get the cube root of x plus 1 is equal to 3. Cube both sides, giving me 27. And then subtract 1, x is a 26. And that wraps up today's lesson, and you need to complete day 16 for tonight's assignment.